Welcome to today video lecture series is the conduction solved problem of a composite wall. A composite wall is made up of two slabs with outermost surface temperature maintained at 1300 degrees Celsius and 115 degrees Celsius. The first slab has a thickness of 500 mm and a thermal conductivity of 1.4 watt per meter Kelvin, and the thickness and the thermal conductivity of second slab are 161 mm and 0.35 watt per meter Kelvin. Calculate the conduction of heat transfer through this composite wall per square meter, and the temperature of the surface is contact. So in this problem, which is consider this is an composite wall, this is on layer 1 and this is on layer 2. Here we are indicating the properties of this layer 1 and here we are indicating the properties of that layer 2, and from the given data the temperature of this outside part is 1300 and inside is 115 degrees Celsius, and length of the composite wall is 500 mm and 161 mm, and thermal conductivity of the slab 1 is 1.4 watt per meter Kelvin, and the thermal conductivity of the slab 2 is 0.35 watt per meter Kelvin. So previous videos we already discussed about the heat transfer is equation is equal to del T by R. So here del T is a temperature difference and R is a resistance. So here R we are indicating the both two slabs resistance R1 and R2, and basically we know that the formula of resistance R is equal to L by Ka. For indicating the slab 1, R1 is equal to L1 by K1 A1. So here is the L1 is in 500 and K1 is a thermal conductivity and A1 is a area is length into breadth. Similarly for resistance for R2 is equal to L2 by K2 into A2. So these are the values from our given problem. So finally we get it, the total resistance R is equal to 0.817 Kelvin per watt, and basically we derived the Q is equal to del T by R. Del T means 1300 degrees Celsius and 115 temperature, and the value of R is 0.817. So finally we get it, the heat transfer rate is equal to 1450.18 watt. And another we substitute this heat transfer equation Q is equal to del T by R. For consider a slab 1, this is a slab 1, Q is equal to del T by R1, and the value of del T1 is equal to T1 minus T2 by R1. The Q is equal to, we find out 145018 watt, and we substitute this Q in the final slab 1 equation, we get it the temperature 2 equation. So and final once again I will summarize about this problem is, here given two slab of composite wall and properties of the two slabs are also given. We need to find what is the heat transfer rate and what is the intermediate temperature of this composite wall. So first we find out the basic equation of heat transfer of the conduction is del T by R. So here is the R is the resistance of the slab, is a formula of L by Ka. So we need to substitute this L by Ka in both section as well as section 1 and section 2. From the given properties we get it the final consolidation R resistance of the composite wall, and substitute this R value in this basic equation Q is equal to del T by R. Is the del T is the temperature difference, and we get it the basic heat transfer is 1450.18 watt. And the second part we need to find the intermediate temperature. So for this intermediate temperature we get it, we are take it one slab from this given two slabs. So here we get it this slab 1 and substitute the slab values and substitute these R values and Q values from the slab 1 R equation. We get it the final intermediate temperature of the composites wall. Thank you.